Beneath your feet, the moon's hidden activity. As you stand on the lunar surface, an eerie sensation washes over you. The moon beneath your feet seems to pulse, a silent warning of unseen forces at work. Suddenly, a powerful tremor knocks you off balance. Could this be a moonquake? For years, scientists believed the moon was geologically inactive, a lifeless satellite. However, recent discoveries challenge this notion. Researchers from the University of Maryland have identified 266 mysterious ridges on the far side of the moon. These formations suggest that geological activity may still be occurring beneath its surface. Are we witnessing moonquakes? These ridges are found in regions shaped by volcanic activity between 3.2 and 3.6 billion years ago. Yet, they appear much younger than expected. Typically forming in clusters of 10 to 40, they often emerge in structurally weak areas of the moon's crust. When scientists describe something as recent, they don't mean last year or even the past decade. Geological time operates on a much larger scale. Most models previously suggested that the moon's geological activity ceased 2.5 to 3 billion years ago. However, the new findings indicate that some of these formations may have developed within the last billion years. Some smaller ridges may have formed as recently as 200 million years ago, an astonishingly recent event in lunar history. This suggests that the moon might still be experiencing geological changes today. How do scientists know? To estimate the age of these ridges, researchers used crater counting. The principle is simple. Surfaces with fewer craters are younger, while older regions accumulate more impacts over time. Additionally, some ridges cut through existing craters, indicating that they formed much later, possibly around 160 million years ago. Another key observation is the similarity between ridges on both the near and far sides of the moon. This suggests they may have been formed by the same geological processes, possibly driven by the moon's gradual contraction, thermal changes, and shifts in its orbit. The moon's shrinking mystery. Decades-old data from the Apollo missions hinted at lunar activity long before these new discoveries. The Apollo lunar seismic experiment detected 28 shallow moonquakes, ranging in magnitude from 1.5 to 5. These tremors suggest a connection between the ridges and ongoing seismic activity. The moon's history begins around 4.5 billion years ago when a Mars-sized object collided with Earth. This impact ejected molten material into space, eventually coalescing into the moon. Initially, the moon was a molten world, marked by intense volcanic and seismic activity. Scientists now estimate that it solidified around 4.43 billion years ago, a turning point not only for the moon but also for Earth, as this event likely contributed to our planet's long-term stability. Despite its apparent stillness, the moon continues to cool. As its core contracts, the surface crust cracks and shifts. Evidence of this process can be seen in the lunar maria, large, dark patches formed by ancient lava flows. Over time, the cooling and contracting crust gave rise to wrinkle ridges, much like those newly discovered formations. How lunar activity affects us. The ongoing geological activity of the moon raises concerns for future lunar missions. For years, the moon has been seen as a stable location for bases and resource extraction. However, if the surface is still shifting, infrastructure and settlements could face unexpected risks. This makes it crucial to deploy advanced seismometers and ground-penetrating radars to understand the moon's movements better before long-term missions begin. Another challenge is lunar dust, or regolith. Apollo astronauts quickly discovered how invasive this jagged, electrostatically charged dust could be. It clung to their suits, damaged equipment, and even caused health issues like eye irritation and respiratory problems. Now, new research from Texas A&M suggests that lunar dust could pose an even greater threat. Rocket landings and takeoffs stir up this fine material, creating hazards for spacecraft navigating the moon's surface. Searching for water, a game changer. Beyond geological activity and moonquakes, scientists are focused on a critical question: is there water on the moon? China's Chang'e 7 mission, scheduled for 2026, aims to investigate this mystery. A flying robot will explore the deep craters of the moon's south pole, where ice may be trapped. If confirmed, this discovery could transform future lunar missions by providing astronauts with a vital water source, and even fuel for space travel. Although previous missions, including NASA and Indian space probes, have detected traces of water, the true potential lies in deep ice deposits. These could make long-term lunar missions more feasible and cost-effective, enabling humans to live and work on the Moon. What else is the Moon hiding? The discovery of young lunar ridges forces us to reconsider what we thought we knew about our closest celestial neighbor. If the Moon is still geologically active, what other secrets might it hold? Could future missions uncover even more unexpected phenomena? As space agencies prepare for upcoming explorations, one thing is certain: the Moon is far more dynamic than we ever imagined. The coming years will reveal whether humanity is truly prepared for the challenges of living on a world that is still shifting beneath our feet. If you found this information intriguing, be sure to like and share this video. And for more fascinating insights, stay tuned to Factonic.